Have you ever really stopped to think about what's happening inside your computer when you do something simple, like click a button? I mean, really think about it. We're going to pull back the curtain on that little piece of magic, that split-second process that powers literally everything you do on a screen. All right, let's get into it.
So yeah, you click an icon, you tap your phone screen, you type a letter. It feels completely instant, doesn't it? But in that tiny, microscopic sliver of time between your finger moving and something happening on screen, what is the machine actually doing?
Well, here's the secret. It's not one big, complicated action. Not at all. Your computer is basically a genius at one thing: breaking down huge, complex problems into the tiniest, simplest instructions imaginable. And then it just does those simple tasks over and over and over again at a speed that's, well, it's almost impossible to wrap your head around.
Okay, so to really understand how this all works, we've got to meet the team. The crew working inside what we call the Central Processing Unit, or CPU. You can think of these guys as the specialists, and each one has a very, very specific job to do. And here's our lineup. We've got the program counter, your main memory, that's RAM, the control unit, the arithmetic logic unit, and these super fast little storage spots called registers. Every single one of them is absolutely essential to get even one command processed. So let's get to know them a little better. First up, we have the program counter, or PC for short. This is the navigator for the whole operation. Its only job, its entire purpose in life, is to keep track of where we are. It's constantly pointing to the memory address of the very next instruction that's in line.
Next, there's the control unit, the CU. This is kind of like the project manager, or maybe the translator. It takes an instruction, figures out what on earth it's supposed to mean, and then barks out orders to all the other components, telling them exactly what to do and when to do it.
And now for the muscle of the operation, the arithmetic logic unit, or ALU. This is the calculator. Anytime a program needs to do some math, like adding or subtracting, or make a logical decision, like checking if one number is bigger than another, the ALU is the component that actually gets the job done.
And rounding out our crew, we have the registers. Think of these as a tiny, super fast workbench sitting right next to the ALU. Now you might be asking, wait a minute, don't we already have memory or RAM? And yeah, we do. But RAM is like a giant warehouse. It holds a ton of stuff, but it's kind of slow to get to. Registers are like the tools and parts you have right there on your workbench, ready to go. They are all about immediate access and pure speed.
So now that we've met the crew, let's see them in action. You see, every single instruction that a CPU handles goes through the exact same four-step process. Every time. It's called the instruction cycle.
It all boils down to just these four steps: fetch, decode, execute, and write back. It's this simple, elegant, and endlessly repeating loop that is literally the heartbeat of your computer. Let's break it down.
So it all kicks off with fetch. The program counter points the way and the CPU reaches out to the main memory, the RAM, grabs the next instruction in line and pulls it inside to a special little holding area.
Okay, once the instruction is inside, we hit step 2, decode. The control unit takes a look at this instruction, which, remember, is just a bunch of ones and zeros, and it translates it. It figures out, okay, is this an add command, a move data command? What are we doing here? And that leads us to the main event. Execute. The control unit sends out the signals. Maybe it fires up the ALU to do some math, or maybe it just shuffles some data around. This is where the rubber meets the road. This is where the work actually gets done.
And finally, you got to save your work, right? That's write back. The result of that execution can't just float around in nowhere land. The CPU has to store that new piece of information either in one of those super fast registers or back out into the main memory. Let's make this super concrete, okay? Let's say the instruction is just to add two numbers. Simple. In the fetch step, the CPU grabs the add command. In decode, the control unit recognizes, aha, this is addition. In execute, the ALU does its thing and adds the numbers. And in write back, the answer gets stored. 4 steps, one simple task, done. So this 4-step cycle seems pretty straightforward, right? But how does that simple little dance lead to the incredible instantaneous speeds we get from our devices? Well, the secret isn't just the dance itself. It's the unbelievable scale at which it's performed.
So, when you hear about a 3 GHz CPU, that means there are 3 billion clock cycles every single second. Now, that doesn't mean it does 3 billion full instructions per second, because each of our 4 steps can take one or more of these cycles. But still, that's the fundamental rhythm, the drumbeat, pushing this whole process forward at a mind-boggling pace. But here's the thing. Raw speed isn't the whole story. Modern CPUs have this absolutely brilliant trick up their sleeve to squeeze even more performance out of every last one of those clock cycles. It's an idea that completely changed the game.
And this right here, this is the secret sauce. It's a technique called pipelining. See, instead of taking one instruction and running it through all 4 stages before starting the next one, the CPU works like a factory assembly line. Think about it. A car factory doesn't build one entire car and then start the next one. No way! It's working on hundreds at once, all at different stations. And that's exactly what pipelining does. While one instruction is being executed, the very next one is being decoded, and a third one is being fetched, all at the exact same time. It's this parallelism that makes modern computers feel so incredibly fast.
Okay, so we've been way down in the technical weeds of the CPU. Let's zoom all the way back out. Why does understanding this tiny 4-step cycle even matter? How does this connect to you, sending an email or playing a video game?
Here it is. This is the crucial connection. Every single thing you do, every click, every tap, every key you press unleashes a firestorm of these fetch, decode, execute, write-back cycles. Millions, sometimes billions of them, every single second. This is the exact point where your software command becomes a physical action in the hardware.
And if you take one thing away from all this, let it be this. Our computers don't have some mysterious, hidden intelligence. They don't understand things. They are just incredibly powerful but fundamentally simple machines that execute basic commands. The magic, the illusion of intelligence, that all comes from doing this simple thing an absolutely absurd number of times per second. So the next time you see your computer doing something that just seems amazing, remember what's really happening under the hood. It's not thinking the way you and I think. It's performing a perfectly choreographed, 4-step dance at the speed of light. And that, in its own way, is just so much cooler.